Let's talk a little bit more about Hive now, what we have seen earlier. So we will see how do we do joins in Hive. Okay, we have already implemented partitioning before. How to write your custom scripts, how to create your UDF, and if you wanted to spool the contents of the file to a particular location, that is also what we will be seeing here. That's what we are going to touch base on this particular module. Okay, so what are we doing here? I have got a data file called as employee.txt and an email.txt having 4 records each. Okay, so I'm creating an employee table, and I'm loading the data from the employee text into the employee table. You can see over here what would happen. Then what am I doing is I'm creating a mail ID table, and I'm loading the data from the mail ID. So I have got two tables called as mail ID, and I have got employee table. Then I'm showing you how to do a normal Cartesian join or an equi-join. So if I say select a.name, a salary, b.email from employee A, that is an alias, join mail ID B on the name, you will see that it will return me only the values which is there in both the data sets. You can also try a left outer join, wherein you will see all the values whatever is there on the first table, that is the employee table, that will be shown, and even if the mail ID does not have the value, you will see nulls coming. That is how your left outer join would work. Similarly, you can do a right outer join. So in the case of a right outer join, all the records of the second table would be coming, that is a mail ID, and on the first table, if there are no values, you will see nulls coming in. And if you do a full outer join, you will see that all the records from both the data sets will come. Wherever it is not present on the other side, you will see joins. Okay? Cool. Dheeraj was asking me, can we create primary key, unique key in Hive tables? No, you cannot do that because the data has already come. There is no validation here, Dheeraj. That is something that we will have to be cognizant of because the data has already come. If the data has got duplicates, creating a primary key would not make any sense over here, Dheeraj. Okay? Hope it is clear for you. Cool. So these were the various joins that we have. Remember, we did dynamic partitioning when we did the example on last Saturday, and I have set 3 values, right? How to do the partition mode as non-strict, dynamic partitioning is true, and bucketing is enabled. So that is what I'm showing over here. Okay, so how Hive partitioning can be done, guys. Cool. Here, let me have a look at the questions window now. Dheeraj said, while loading data from external tables, can we select unique value? That is possible. So when you are loading values from external table, you can definitely select the unique values. You can decide what is the distinct of the values. That is possible, Dheeraj. So our source table is transaction records, and the partition table is transaction records by category. This is what I had shown it to you last time. Then I will load data into the partition table. This is also something that I had shown it to you last time, guys. We have actually demonstrated this particular code. Okay. Now, in case if you are having some logic wherein I wanted to use my custom Mapreduce scripts. So HiveQL will allow the traditional Mapreduce developers to plug in their custom mappers and reducers to do something that is not supported by the capabilities of the language. So for that is possible. So why do we do partitioning? So that I'll have faster access to data. Why do we do bucketing? So that I will be ensuring that all the values with the same hash will go down to the same bucket. That's what we had seen last time. So this is where we are going to see how to plug in a custom Python code. Okay, so we are going to use our custom Mapreduce code to do some analysis. Have a look at this. So what do? I first create a table. Okay, user ID, movie ID, rating, Unix timestamp. Okay, and then I will load the data from a file called as u.data into the table udata. So what is that? That is nothing but this user ID, movie ID, rating, and the timestamp. These values is what I'm loading into the table, friend. Okay, so but all are going to the second bucket. Okay, so show me the script that you are running. It should not happen because last time I had demonstrated to you, Mallikarjuna. Depends upon what data set are you using. Are you using the same data set what I had used, friend? Because if you use it then it should work. So now let's move on, guys. So we have seen how to create a table and load the data. Now I am having a custom Mapreduce script. Okay. So here, thank you so much, Vineet. So this is the link that you can look at, Mallikarjun. Okay, you can copy at this link. You can look at this link and you will be able to get the TXNS file. Please try with the TXNS file and let me know. Same thing goes for one of our other friends, Dheeraj. So please try the partition data with this TXNS file and let me know what the results are. Okay, so what are we doing? We are creating a file with a Python script. This is what is that Python script doing. What is it doing? It is converting the timestamp what you're having. So what are the timestamp? This is what are the timestamp that we had in our data. It is converting that particular timestamp what you're having. Sorry. It is converting this timestamp what you're having into your weekday. Okay. Then I'm creating one more table called as u_data_new. Okay, and then I am going to add my Python file. Okay, so you'll see how the resource is added, and then you will use a function called as transform. So the columns will be transformed to string and delimited by tab before feeding to the user script, and the standard output of the user script will be treated as tab separated string columns. Okay, so what do? I say insert override table. So now what are we doing? I said insert override table, and then what do? Select transform. Okay, using whatever is the file that I'm having, and then I say as from the table name. So what are we doing over here is we are using the transform class, okay, to embed the mapper script that we have in the code. So what are we doing? We are converting the timestamp into days over here. Okay, and once you do that, this is what would be the final output what you'll be seeing. When you say select weekday, count star from group by weekday, you'll say for every weekday how many values are there. So this is the way how you can transform something using a external Mapreduce code. So here I have used a Python script for doing it, folks. Okay, perfect. Now you can also create, like pig, you can also create a user-defined function. So what is the user-defined function that I'm having over here? I'm creating a user-defined function called as lower. All user-defined functions should extend a class called as UDF. In pig, we used to extend eval function and filter function, whereas over here in Hive, you have to extend UDF. The method will always be called as evaluate, which will take a text and return whatever is a business logic. So in this example, we say that whatever is a text that is coming, we will return a lower case of that particular text. Once that is done, you will create a function, okay, as so and so that I can use this function in my code, and then you see how I am using that function. I'll say select edu_lower title, some frequency from titles group by so and so. Okay, so more detailed example of how to use a UDF is available in the wiki page. So why would you use UDF? In case if you want to have some functionality which is not readily available, we will say here once again we will once it's not readily available, we'll create a UDF. Vineet had a question. He was saying the class name is lower, but the code says edu_lower. The reason is because I have created a function. See here, this is the alias name that I can use for that class called as lower. Okay, good. Vineet have understood it. That's nice, mate. Thank you so much. So this is what is the UDF that we have, guys. Now, you can also use your Hive to connect to a Java code. Okay, so supposing if you're having a plain Java code and I wanted to fire some SQL query from a Java code, so for how do I do it? How do I connect to a Hive machine? We do it through something called as a thrift server. So first part is you should run the thrift server. So this is the way how you would be running actually the service. Once you do that, you will be able to connect to it with this particular port number. Okay, 10,000 as a port number. So how do we do that? You will use the driver name. This is like a standard JDBC code. Class.forName will be the driver name. Then you will use a connection to connect to the driver using JDBC:hive: the IP address, whatever is the name of the port number that you have said and what is the default database. If you have any username password, you can give that also. Create a statement, get a result set, and simply loop through it and print out the hash and the category, friends. So what am I trying to show over here? How to use your Hive to Java Hive code to like a JDBC code to connect to a Hive system. But that can be done only if the thrift server is running. Remember last time we had discussed about thrift. So this is the same thrift that we are talking about. Cool. Hey, Nandish was asking, where do I put this file UDF? This file would be typically be in the form of a jar file. So you can put this file anywhere. Okay, whenever you create a file, typically it should be there in the class path. So if you create a jar file and if you put the jar file in the lib directory of your Hive, that should work, Nandish. Okay. So that's it, guys. So this is how you will create your UDF. And we were talking about how to have Hive running through a thrift server. So now if you look at the final project that we are going to see on the last day, you will see that we are having huge raw XML files. You will use HDFS, Pig, and of course you will use Hive as a part of the project to convert to do some SQL query on your data, and then using Scoop you'll be pushing it into your MySQL database. So let's get started with our plan of action for today. So today we are going to start with NoSQL. So when we talk about NoSQL, let's look at some of the problems in the real world. I'm sure a lot of people who are sleeping would have woken up by looking at Angelina. Okay, but then we are not talking about Angelina here. We are talking about Twitter. Okay, guys. Then we have got, as compared to Angelina, duck cutting is not that interesting. Okay, but still he is the founder for our course that we are doing, that is the Hadoop. Here I am talking about primarily about LinkedIn. And if you look at Facebook, we are shamelessly showing our own page of Edureka, okay, showing you how we are trying to revolutionize education. And typically when we go down to a new location, at least I would want to check the speed test so that I know that, because I do a lot of deliveries. So, and when we talk, we also nowadays talk only via the VoIP. We don't talk via the call. So we do speedtest.net, and over there also you see an Edureka ad coming in. Okay, so this is ad targeting is what I'm trying to emphasize over here. So I emphasize 3 social media details. Cool, guys. So what am I trying to show over here is the way Hadoop and NoSQL will be going hand in hand. So first and first forth, let me go ahead and create today's document. So I'll go down to customers. I'll go down to Edureka. I'll go down to Venkat session, Feb 11. Right click, come on, Neo, text document, I'll call it as date10.text, okay, and if I try to look at what all are the restrictions of your plain Hadoop. Yes, Hadoop is not suitable, plain Hadoop is not suitable for all the details. So if you look at what all are the limitations of, let me increase the font. The font is too small I mean. If I go down to the screen font and set font, and I'll make it as 18, apply, okay, that's better. Limitations, I should not say limitations, it's typically the restrictions of Hadoop or HDFS and Mapreduce is first, it is only batch processing and not real time. Second restriction is it allows only append because the access pattern is worm, write once, read many, and no update capability. And the third advantage of that is, third restriction is it always analyze a file and no random read or write of records possible. Okay, so what it actually means is, in case if you want to look at a single record, that capability is not possible. So these are the three main restrictions of plain Hadoop. And if you wanted to get real time, if you wanted to get update capability and random read and random write, you will have to go down to NoSQL. NoSQL, specifically HBase, will give you all of these capabilities, folks. Okay. So with that context, let me continue. And guys, please have your VM ready because we will be doing some hands-on on the VM today. So please have your VM ready, folks. Let me log in into Edureka. There we go. I'm interested in knowing my daemon so that everything is ready. Cool. So while the login happens, let's continue. So what did I show you? I had shown you LinkedIn, Twitter, Facebook, and ad targeting. So what is common in all of these four corners or four different sites or links that I have shown? All of them have got huge amount of data. All of them need random access. That means I'm not interested in a complete analysis of all the file. I'm interested in an individual record, and I wanted to analyze the record. All of them are primarily structured data. The need of the hour is that you would need a variable schema. So if you look at primarily our standard RDBMS, the structure needs to be defined first, and then only you can add something to it. Whereas over here, the schema is varied. You will have a frequent amount of schema changes, etc. So if I want a variable kind of a schema, I cannot go for relational data stores, and that is the reason why I go for NoSQL. Please understand, till yesterday we were talking about batch processing. NoSQL is what is online or real-time processing, okay? So we are no longer talking about batch processing now. We are talking about online or real-time processing. Then, is it possible to compress some of the columns? No, not possible. Is it possible to cache some of the columns? Again, not possible. So if you have those requirements, if this is what is the need of the hour, okay, if you need the following capabilities, take an example. I have got a table with 10 columns, and I am selecting column 1 and column 9. Okay. Okay, selecting column 1 and column 9 from the table. In RDBMS, how many columns will be selected internally? Of course, it has to be 10, friend, because everything is stored in the form of a row. Okay, so we need to understand the difference between the row storage that is happening in our RDBMS and the column storage what is happening in our HBase. For people who are there in the Microsoft world, they have the SQL Server already have got a column storage. So further reading on the row storage and column storage, you have to do this. So look out primarily for columnar data store. It'll take you to Wikipedia. There it is. Let me do Control plus, so that will become a little bit big. See over here, column-oriented DBMS. So this is the article that you will have to understand. So there are 4 types of NoSQL. Just one sec, friends. So Control End. This is the article that you'll have to read about column-oriented data store. So let's understand this. So you see here, a column-oriented database is a DBMS that stores data tables as sections of columns rather than rows. In comparison, most RDBMS stores data in rows. This column-oriented DBMS has got advantages for data warehouses. Data warehouses internally store it in the form of column-oriented. And the advantage is whenever you want to have aggregates, it will be blazingly fast because everything is stored in the form of a column and not a row. Okay? Perfect, Vijay. So this is an article that you will have to look around and play around with. Okay, so now coming back, sorry, let me go back to this. So of course it is going to be 10. It is going to internally select 10 columns, but I have asked for only 2 columns, and if I want that capability, I would need to go for some other thing other than RDBMS. This is the first problem. Second problem, can I compress some of the columns in a table in RDBMS? Because some of them are blobs and clobs, that is not needed. I can compress the whole table, but can I compress some of the columns? They say they can. A lot of these new functionalities will be coming, friend. Okay, in 11C they say that because these are all the requirements of the market. So what is happening is that the RDBMS is doing a catch-up game, right? So primarily, can I cache some of the columns? I wanted some of the columns is frequently used. Is it possible to cache some of the columns? Okay, so primarily no, you cannot cache some of the columns. No, I don't think any RDBMS is still supporting it. Okay, and the last one, database guys, don't fall down. Okay, if I ask you this question, okay, can I add a row when, can I add a column when I am adding rows to the table? That means, can I have a dynamic schema? We spoke about variable schema, right? So if you need any of these capabilities, okay, and there is when you want limited dependency on the structure of the table, if you want any of these capabilities, then you will have to go for NoSQL. Okay, if we need the above capabilities, then just one sec, too many windows for me, my dear friends. Let me move that window. Then the solution is to go for NoSQL. So NoSQL, typically interpreted as not only SQL, although that is not the right definition. NoSQL, can anybody let me know how did the word NoSQL came? So NoSQL is actually a hashtag. It's a Twitter tag that was created by Johan from Last.fm, okay, in the year 2009 when they were promoting an event for non-relational databases. So what is NoSQL? NoSQL is primarily a type of a database that gives you storage and retrieval of data modeled in other than the relational tables that we have in our RDBMS. So that is what is the concept of it. Very good. Very good, Vineet. So this is what Vineet had mentioned. Hey, Ruchir had some point. Let me just put it across to everybody, and then let me just myself go ahead and have a look at it. So Vineet, Ruchir is saying that this is a very good introduction about NoSQL. Just give me one sec. Let me see if I remember seeing this video. This is one of the best videos of NoSQL, friend. You are correct on that. Okay, this is there in the same GoTo conference. Okay, no worries, friend. So you're also right. So this is the right one. Cool. So Mallikarjuna was saying we do use for caching HTML and JSON data, non-structured data. Hey, you can put in that way also. So there's a lot of use cases, Mallikarjuna, on the NoSQL. Cool. So now let's again go back to the complete Wikipedia page and understand what is this NoSQL. So you can see over here, the NoSQL databases are increasingly used in big data and real-time web applications. Okay, so that is what is the biggest use of NoSQL. And in NoSQL, there is something called as a CAP theorem. Okay, we know what is ACID: atomicity, consistency, isolation, durability, and RDBMS. Okay, whereas here we are what is this? Oracle pinning close to cache. I didn't understand, Srinivas. Yeah, that's right. So CAP theorem is consistency, availability, and partitioning. So there is no ACID capabilities, although that is coming up in NoSQL nowadays. So let's look at what is this CAP theorem. I'm going to right click. Come on, why my mouse is not doing a right click? Oh, finally I got it. My mouse, I need to change my mouse. So if you look at CAP theorem, you will see that in theoretical science, that's right. Very good, Vineet. Only 2 out of the 3 can be achieved. Good point, Vineet and Srinivas. You have done your homework. I'm impressed. Okay. I'm especially impressed with you, Vineet, because you are a database guy and still you have done these things. That's good. I presume you're a database guy, right? Because I know you're very comfortable with SQL. I don't remember your background, but then I think you're a database guy. So when we talk about CAP theorem, it is Eric Brewer from the Berkeley University, the same university from where your Spark has come. Okay, so he had mentioned in the year, way back in the year 2000, that it is impossible in a distributed computer system to provide simultaneously all the 3 capabilities. So what are the 3 capabilities he's talking about? Consistency, everybody sees the same data, there is no dirty reads. Availability, a guarantee that every request will receive a response whether it is succeeded or failed. And partition tolerance, which means even if there is an arbitrary message loss or a failure on the part of the system, still it will take care of it because the data is going to be partitioned. So he said that out of the 3 capabilities of CAP, it is possible to achieve only 2 and it is impossible to achieve all the 3. I'll be showing an image wherein I will substantiate what I have just mentioned right now. Okay, so now coming back to this NoSQL, so there are 4 types of NoSQLs, 4 categories of NoSQLs. Let's go down. This is where I had mentioned, so it was actually Eric Evans who had introduced the term NoSQL. It's a Twitter hashtag when Johan from Last of Him organized an event to discuss open source distributed databases. There are 4 types of NoSQLs. You will have columnar data stores. That's what we are going to talk, wherein you'll have HBase and Cassandra as the base. You have got document-oriented data store, wherein you will have MarkLogic and MongoDB, and of course CouchDB. Key value pair, wherein you will have Redis and Riak. Then graph database, wherein you will have Neo4j and Titan. Titan is not shown here. It is also good. Just give me one sec, guys. Back again. So, and they have also got something called as multi-model, but that is not really a type, friends. Okay. So there are 4 types of, 4 categories of NoSQLs. So for anybody who wants to, that's correct. Multi-model is a new thing. Even I haven't heard about it, friend. So Wikipedia is trying to come out with a new category called as multi-model. I haven't heard about it. But then this is a good site wherein you can look at the performance across, performance scalability, flexibility across all of the different data stores. So have a look at this article, friends. So this is what is NoSQL primarily. So what happens in NoSQL is, let's go ahead and specifically with reference to HBase. Okay, so if you look at HDFS and or let's say Hadoop in general, HDFS should be fine. And let's look at NoSQL. So in HDFS we had, oops, I should take this fellow up and I'll put it over here. So in HDFS we had something called as name node. So what was a name node doing? It was talking to the clients. It was acting like a project lead, okay? And it was also talking to the slaves. That means it was acting like a team lead also. They realized that this was getting overloaded. So that's why in HBase, they have separated this responsibility of talking to the clients to a component called as Zookeeper, and for talking to slaves they have got something called as HMaster. And please remember, HMaster is going to be active and passive. Okay, then we had something called as data nodes. So over here, the data node is done by something called as region server daemon. Okay, these are all different daemons that will come up, okay? So in Pig and Hive, we saw there were no daemons. It was basically applications. It came up with a console, whereas over here you will have daemons. Then we had something called as blocks. That is what is called as regions over here. So this is what is the comparison between your HDFS and HBase. So there's a very important concept called as sharding, which means spreading or distributing data across multiple nodes. So like your Hadoop, we will have a master, you will have a slave, just give me one sec, 1, 2, 3, 4, and 3, 1 sec, 4 and 5, okay? So these are the 5 slaves that we have. So if you have got a table with 1,000 rows, the way how the data, typically in your RDBMS, what would happen? It will be stored in one machine because RDBMS was never designed to be distributed. But over here, what would happen is based on the row ID, okay, it will get distributed across 5 machines. That means from 1 to 199 would be on one, from 200 to 399 would be on second, from 400 to 599 would be on third, 600 to, am I correct? 200? Yeah, that's right. 600 to 799, and then from 800 to 999 would be there on the 5th machine. So this is the way how the data would get distributed. Okay. Hey, HMaster is, when I say master, it is HMaster who will ensure that the data gets distributed across to the nodes. All of these things, what is 1, 2, 3, 4, 5, they are called as region servers. And the part of a table which is there on every node is called as a region. Hey, when we say 1,000, this should actually be 1,000. It should not be that. It should actually be 1,000. You are correct. Okay, cool. So Srinivas was asking, is the distribution sequential? Yes. So that is what is taken care of by the HMaster. That is what is called as sharding. Okay, friends? So if you look at the slide, you will see the need for distribution sharding is one of the biggest advantage of your NoSQL, which you don't have in your traditional database because database was never designed to be distributed. So now let's move on. Now before I go ahead, I wanted to show you about the cap theorem, guys, so that you know what is this cap theorem. That's right, Jayashree. So she just confirmed what I just said. A single table is not distributed. So now before we go ahead to the next slide, I just wanted to show you a cap theorem images. And let me go down to this image. And let me click on view page. And let the page come up. Yeah, there we go, guys. So, so if you look at this image, before I go ahead, one final question over here. Will framework create 3 copies of record, 1 to 99 to avoid a single point of failure? Hey, HBase is going to be a layer that is above HDFS. All the data is finally stored in HDFS. So yes, in HDFS, everything is replicated. So the redundancy is provided by HDFS and not by HBase. Okay? So like in Oracle, if something goes wrong with one machine, the data is gone, right? So although you might have backup and all of those things, but then not at real time, right? Whereas over here, it internally looks at your, this one, it internally looks at your HDFS and does the redundancy. So now coming back to our cap theorem. So if you look at this, you will see that there are 4 categories. As you can see over here, there is a relational data store, there is a key value, columnar, and then you have got document. So what does CAP say? Availability, C is consistency. All the clients will have the same view of the data. Availability, each client can always read and write the data. And partition tolerance is the system works well despite physical network partitions. Okay, so out of this three things, capabilities, most of the NoSQLs will give you partition tolerance. That means your data can be sharded, it will be spread across multiple nodes, and it works well despite the data being there on multiple nodes. So that means you can choose only between C and A. So that's why you will typically see terms like AP and CP that is available in our NoSQL world. So you cannot have, our RDBMS was ideally CA. Why? Because it was never partitioned, so it gave you both consistency and availability. All the MPP tools like Greenplum, Vertica is also of the same way. But when I talk about AP, Cassandra and is more of AP. That means it is more of availability. So websites typically would have Cassandra, etc. Whereas if you want consistency, typically it is going to be CP. So it is going to be consistency. So you will have, by the way, the whole concept of HBase came about from a white paper in 2006 by Google called as Bigtable. So Bigtable along with that HBase is all consistency and partitioning. So that is something that you have to be aware of. Okay. Hey, Srinivas was saying, okay, can you put a link of this page? Sure, why not, friend? Vineet was suggesting if I can give a link of this page in the day2.txt. Why not? There we go. So I will just mention over here, cap, theorem, link, okay? So that it will be easy for you. So let me minimize this. So that is taken care of. With HDFS and HBase, are we not close to cap all three? No, not really, because HBase primarily would be either looking at, when I say availability, we are talking about highly available. That means, think of this way. I'm sure you would have heard about, I don't know about US, but in India there are two sites that I would like to give you an example. So you have got something called as bookmyshow.com. Okay, and then you have got IRCTC, which is a online railway ticket booking site. Okay, bookmyshow.com is for movie booking. Okay, so now think of this way, guys. If you go and book a ticket in IRCTC, you would see that the ticket is available, but by the time you book your ticket, you will see that finally the ticket that you will get might be waitlisted also, or you will get RAC also. That means reservation against cancellation. It is not the same ticket what you saw, right? Make sense? So that is what IRCTC is. So that means what is IRCTC focusing more on? It is focusing more on availability. Whereas in bookmyshow.com, you can actually select a seat and they will, it's not that when you make the payment, you see that your seat gets lost. So they are talking more about consistency. So this is the way how typically a good example to show you what is the architectural difference between consistency and availability, folks. I hope it makes sense. Okay, friends? Cool. So let's go ahead. So this article is very good. You will have to go through this. Let me minimize it. Just give me one sec. Okay, let's get on to the next slide. So if you look at a website of LinkedIn, how does RDBMS solve this? RDBMS typically solve this by having separate tables, and you will be joining the data between the different tables, right? You typically talk about normalization, whereas when we talk about NoSQL, it is completely denormalization. Okay, everything is denormalized, and you will have like a row ID which you can consider like a primary key, okay, which is the one that links everything together. So here between, and you know, joins is the biggest point of performance issues between different tables. You have got multiple small tables all linked together through a primary key and a reference key and a foreign key. Okay, so this is how traditional RDBMS will try to solve it. So now, in case if you want to have a new solution, so what all characteristics are we expecting from the new solution? One, the data should be distributed. Second, the data should be sorted. So this is another beauty of HBase, because sorting in HBase is at 3 levels. Okay, I'll of course give you a demo for showing you that also. I hope all of you have got your VM ready. Just one sec, friends. Let me also go down to my VM and let me open up my, I'm going to start with my putty, guys. Okay, so that will make my life a little bit easy. So just one sec, let me go down to my putty and I will open up my Edureka VM. The username is going to be Edureka, password is going to be Edureka. Very good, right click, change settings, appearance, font. I'm going to make it as a bigger font for you guys. Just one sec, folks. I'm just going to keep everything ready so that when we go ahead with the demo, it will be easy. 16 should be okay. Let me go down to my colors. My default foreground is supposed to be white, and my default default foreground is supposed to be black, and my default background is supposed to be white. And I will say apply. There we go. Okay, so this looks to be big enough. Perfect. Okay, so now let me do sudo jps. Password is going to be Edureka. I hope all my services are running. That's perfect. So to ensure that, okay, so now I'm just wanted to ensure that HBase is all set up. So you will have to say HBase and shell. This is the way how you will get down to the shell command prompt of HBase. Okay, so let it come up. It will come down like you see pig and hive shells. You will see a HBase shell also coming. So this is a little bit more pickier than your other things. So we really don't do the console way of doing it, but for a demonstration purpose, console is pretty good. We typically use a Java way of doing it. So this is what is important. So now I'm just going to say list, which will show me how many tables am I having in my HBase. So list is going to give me the list of tables that we have in our HBase. Let's wait for a couple of seconds. It will go ahead and give me the complete list, guys. Okay, oops, what is happening? Something is wrong. Let me go back. Okay, there we go. Okay, let me come down. Looks like I have to do a sudo restart. See, it will give you a Zookeeper connection exception in case if HBase is not running. Yeah, that's right, that's right. Deliberately I had given this. Exactly, I have to start HBase. So I just wanted to show you what would happen. Okay, so the services are not running. I did sudo jps, right? So the services are not running. And if you look at the document, you would see in our README document what we have in our VM. It will show you how to start with HBase. See over here, in case HBase is not started or not working properly, please do this. Okay, to start HBase, we will have to say start HBase and then go down to the HBase shell. Okay, friends? So, good. So, nothing can happen here. I'll do a control C, I'll do a clear. Okay, suddenly it didn't strike me when I saw the error. Okay, so now I'll go to cd space / usr lib HBase and bin, and then I will say / start HBase.sh. Okay, this will actually start the different 3 important services that we need. Okay, Srinivas was asking there's HBase start and HBase daemon.sh. Okay, typically it will be HBase.sh, my dear friend. So the password is Edureka. Okay, see here it is starting Zookeeper, it is starting master. Okay, and that is enough. So it is again asking me for a password. Let me click and put in, just one sec, what is happening? For some reason it is not highlighting. Wait for a couple of seconds. Okay, now it has coming. No, let me type this. I will say, hey, why am I not able to type? Just give me one sec, guys, please. I got no clue why it is not allowing me to type in. Just give me one sec. Nothing wrong with my stuff. It is just that it is not accepting a console input. Let me go ahead and say duplicate session. I'm going to log in as Edureka. Password is going to be Edureka. Let me close my earlier session. Something has gone wrong over there. Let me do a sudo JPS, and the password is going to be Edureka. And you see here that I have got my HMaster. That is going to be the HMaster, what I said. I have got my HQuorum peer. That is going to be the Zookeeper. So now let me say HBase shell, and I will press enter, and it will come down to the console. Once I come down to the console, I am going to say list, which will check whether the database is running or not, friend. Okay? So let's test it out. I want all of you to actually test it so that you can actually try with example, guys. There we go. I'm just going to say list, and I'll press enter. It starts with something called as table. Let's see what it does. The daemons are running, guys. Okay, see over here, I have got 3 tables that is there with me. I have got scores 1 and sample, and you might have only a table called as scores. Okay, so don't worry about it. I have got more table because I have played around with it. That's why. So this is how you will see everything. So now what I want is, I'm going to say, if I want to delete something, I will say disable single quotes scores 1. Okay, I'll press enter. No need for a semicolon at the end of the line. And then I will say drop scores 1. So these are all the syntax that is there in case if you want to play around with it. Okay, so I'm disabling, and then I will be dropping the scores also, scores 1. Because scores and sample are the tables that I have created. Okay, connection refused. Just once again. I said disable single quotes SCORES scores 1. Okay, just once again, I'll say describe scores 1. Okay, it is enabled. Let me see what it is doing. For some reason it's saying connection is not there. So maybe my complete connection is not done. I'll have to just do a restart. Okay, so that should solve my problem. I mean the daemons. See here, I get it. So I'm just going to say exit. Okay, so I will actually go ahead and say now cd / usr lib HBase and bin, and I'll say / start HBase. Oops, start HBase.sh. This will start your services. Let me see what is going wrong. So if the services are already running, the password is going to be Edureka. Okay, good. So Zookeeper is already running. The master is already running. Now let me give the password as Edureka, localhost. Hey, my region server was not running. Remember last time it got hung up? Okay, so that is the reason. So now if I do sudo JPS, remember there are 2 components. It's like the data node not running, right? So I didn't realize it before. So see over here, there is HMaster, there is your region, that is the data node, the region server, and the HQuorum peer. So it is good what happened now, so that at least you know how things are. Now I'll say HBase shell, which will get down to the console. Good. Let's wait for a couple of seconds. So since the HMaster was running, it was showing me all the listings from the metadata file. But when I said I want to disable or drop, it was not allowing me because the data node was not running. Okay, so that is what the issue was. Cool, friends. Let's wait. Yep, there we go. Now if I say disable single quotes scores 1, disable is a way how first I will have to ensure that no connections are there for that particular table. Okay, and then I can drop the table. Okay, so that is what's here. It is disabled. Okay, now I'll say drop single quotes scores 1. So I'm dropping the table. Cool. See, and now if I say list, you will see that I only have got sample and scores. So what I did was that I dropped a table and I had actually shown you how you will be able to work with it. So in case if you want to get an exhaustive list of commands, just go down and search for HBase commands. There is a very good WordPress site, learnhbase.wordpress.com. So this will give you a fantastic link of all the exhaustive list of commands. Okay, so I'm just going to copy this and put it into your window so that you will be able to see this. Even your Apache wiki also has got a lot of good things. Let me go down and see here. Not this one, HBase shell. It will give you the list of commands what is needed. See this one. So it will give you the complete list. So this page is also good. These two pages are more than enough for you to get started with it, folks. Okay? So I hope you have understood what we have done. I have just started with the table and I have kept, I've started with the table and I have kept everything ready. The next thing is I'm going to give you something that I have personally available. So I'm going to put it, of course, in the copy link also. Just give me one sec. Where is that? I need to go down to my day 4. I have got a file called as hbase.xls, which I'm going to share it with you guys. There we go. I have pasted it in the copy link. So this is to just visually show you how things are going to be executed. Okay. So now if you look at this, so this diagram talks to you on the things what I had already explained to you before. What is the difference between Hadoop and HBase? Can I do real time? Can I update a record? Can I do a random read or a random write? And these are the 5 things that RDBMS doesn't solve. Okay. So the biggest advantage of HBase is, remember Praveen said something about a sparse database. So let's say I have got a table in which I have got, now you will have to get used to the new term called as column family. Okay, so whenever you create a table, what is there is, what is important is the column family, folks. Okay, so, okay, just give me one sec. Okay, there we go. So we have got something called as a column family. So when we create a table, we will only create a column family. Okay, so let's go ahead and see that demo. That's what I'm going to do right now. So I'm going to show you what is the sparse database. A demo is the best way of explanation. So let's create a table. So I am going to say create. Here I already have got sample. I have to drop that. I don't want too many tables. That's the only reason, friends. So I'll say disable sample. Okay, and then I will say drop sample. Drop sample. Okay, we are done. List will show me only one table. This is what all of you will also see. Now I'm going to create a table. So create, I will say sample. The first value that you pass over here is the name of the table. And at the time of creating table, you will have to specify the column families. Column families are the logical or a broader unit wherein all the columns will be added. So completely different from the way how we create a table where we create columns. Okay, now I create a table called as sample. Now I am going to have a column family called as professional, and I am going to have another column family called as personal. Okay, oops, I forgot the single quotes. So single quotes personal. No need for a semicolon anything, and this is the way how a table will be created. See? A table gets created, a H table gets created called as sample. So at the time of create, what should we do? We should give the table name, the column families that I want. Okay, so I'm having 2 column families, professional and personal. Dheeraj, no data type because everything is in the form of a byte array. NoSQL, especially HBase, does not have anything in the form of a data type. Everything is going to be in the form of your, this one, what I call a byte array. Cool. So now, let's describe the table and see what happens. Describe single quote sample. Remember I told you the sorting? So let me go back and first explain that to you. Where is sorting? Okay, sorry, I didn't cover that. Just one sec. So let me do that. Sorting is first done. Sorting is done at the column, family, and then at the column level. Okay. Then sorting is done at the row level. Both of these things are in a descending fashion. So that means the first in, first out. That is what is the descending fashion, the way how it happens. Okay, good. And then you have got the third level of sorting, which is there at the value level, and this is going to be done in an ascending fashion. Okay, so these are the three levels of sorting. Cool? Make sense? So let's go ahead and see this now. So now, if you look at the professional and personal, PE comes before PR, right? Although I added PR first. So when I say describe, you will see that first personal comes and then professional comes. Okay, so everything is in the form of a JSON. Okay, over here you see how there are versions that is there. So by default, everything would be there only for once. Okay, you can change the number of versions that you want. Okay, so I wanted to add one more column over here and show you how you will have multiple versions, because that is one of the biggest capabilities of your HBase, wherein you can add multiple versions. So by default in RDBMS you will have only one version, right? You cannot have more than one version, whereas over here you can have any number of versions. So by default it is 3. So see over here, guys, when I add a record, that is the time when I will add a column, and one cell can have 3 versions. Okay, we'll talk about versions with an alter table later on, but I just wanted to show it to you. So let's add something now. Okay, so I wanted to show you how to do the add. Let me have a look at the name of the people. So let's start something with Vijay. Okay, he's there at the last, V is at the last, right? That's why. So I'm going to say put. Put is the way how you will add something. Put single quotes, sample, comma, the row ID, that is going to be Vijay, sorry. That is going to be Vijay, comma, the column family and the column name. I'm going to say personal, colon, the work telephone number, so that will be professional, personal colon, let's say H, telephone number, home telephone number. Okay, I close my this, and then the value of it, some value that I'll enter. So what did I do? This is the way how you will insert values into the table. You will specify the name of the table, you will specify the value of the row ID, you will specify the column family, the column name, and the value of that. Okay, so now I also have got a cell number. Okay, so deliberately you see that I am adding cell number later on. So this is what is going to be, let's say 3, 4, 5, and I'll press enter. I've added 2 values. Just give me one sec, please, guys. So I have added 2 records. Okay, now first I showed you how sorting happens at the column family level. Now let me show you, when I say scan, scan is what will give me all the details, values of it. You saw how sorting is happening at the column level. Although this was the second column that I added, but it comes first because C comes before H, right? So, and you see something called as a timestamp that comes by default. Although I added 2 records, you will see only 1 row because the row ID is still the same. So this is the way how you will be adding values to it, folks. Make sense, folks? Are we clear on this as to how your sorting happens at the column family at the column level? Okay, I showed you both of these things. Let me have a look at the questions window. Very good, Vijay. So now what I need is, I wanted to show you the sorting at the row level. So what am I going to do is, I am going to add Praveen. So P will be above V. So let me add Praveen. So I'm just going to say, instead of Vijay, I'm going to say Praveen. And I'm going to add as professional details now. Okay, instead of personal, I wanted to show you sparse database. So I will say professional colon, let's say location, and let's say you are in New Jersey. Okay, Praveen? So I'll press enter, and now if I say scan, you will see although it was added third, how it is sorted, and Praveen comes in first. So this is the way how the values will be sorted. So I showed you how sorting happens at the row ID level. Now what I want is, I wanted to show you how your values will be sorted at the table level, I mean at the cell level. So what I want is, let me go back and let me go back to the earlier query. I wanted to do some alter table. Just give me one sec. So if you look at this HBase shell commands, there is a way how you can alter table and add one column, you know. That's what I wanted to show you. I don't remember offhand, friend. So alter table, name, and versions. Okay, so this is the way how you can alter a table and increase the version of a column of something. Okay, so of a column family. So let me go back and do an alter table. So what I need over here, just one sec. Yeah, let me go back to this. So I will say, first I have to say disable the table name. Okay, so that connections to it is stopped. Then I will say alter sample, comma, my name is what I want to alter. Let's say I want to alter professional, okay, comma, the versions that I had was 1. I wanted to have it as 5 versions now, and I press enter. See here, updating all regions with the new schema. So I can add one more column family also at runtime. So I'm just going to say, I'm going to add another column family called as, let's say, family members. Okay. So, and the versions of that I want it as, you typically don't have same family members, let's say uncle and aunt, you might have 2. Deliberately, I'm just going to keep it as 3. I can add this. So now if I say scan, describe, you would see that the values, sorry, first I have to enable the table, disable the table, right? So I will have to enable the table, okay, and I will say describe sample. Okay, see over here how F came in first, because F is there. Deliberately I wanted to have some alphabet which will be coming above your professional and personal. The versions is 3. Then we change the value of professional. Where is my professional? And the versions of that has become 5 now. Got it, guys? This is the way how you will alter a table. Hey, version is a number of copies. We are not dropping the table, we are disabling the table, Srinivas. So disable is only ensuring connections to it is there, and drop is something different. Version means every cell can have multiple values. I'll just give you a demo of that, Dheeraj. So if you wanted to have a time series as to what was your address, initial address, then you changed your address, and then you got a new address. So you wanted to have a time series of everything, right? So the old data is still the same. You are adding new data to it. That is the purpose of the copies. Time series is the biggest advantage of NoSQL. Okay, cool. Vijay was saying we always have to specify at least one column while putting. Yes, you have to specify one. Hey, your column. Good point. This is what Vijay was saying. What am I trying to say is you don't have to specify a column. You can specify a column family. So primarily time series. So a column family will also have a value. So let me just show you something at the put level. So let's say that for Praveen, I am going to just look at professional and say what is the kind of professional you are. So you are a Hadoop developer. Not a designation, but just a normal professional, and I press enter. See how? For even though I didn't specify a column family, I got the value. Now if I say scan and single quote sample, you will see how it showed you for location And for professional, you are a Hadoop developer automatically coming. So it's not necessary you have to give even one row. If you add the 6th version, the first version will be removed. So now let's make some changes and see what happens. Okay, so I had set my professional as 5 versions, right? So now initially for location you were there in NJ. So let's say that you are on a spree of going to different locations. So now let's say you go down to Chicago. Okay, then you go down to London. Okay, and then you go down to come back to our suite India. Okay, and now if I say scan of single quotes sample, it'll always show you the latest version. See? Okay, so that is what is the meaning of ascending. But if you want to see all the values, you can simply say colon, curly braces, versions of 5. Okay, whatever versions you want. Okay, so see, it'll show you all the old versions of whatever was there. So there are 4 values of versions that Praveen had. Okay, it'll show you all the values. Still, it will show you the number of rows as 2 because there are only 2 rows over here. Now, if I want to get an individual only for the location thing, I will say get single quotes sample, comma. If I wanted all the records for Praveen, I can say get and Praveen, and you see it will give you the latest value. The professional, you are a Hadoop developer and location is India. But in case if you want to get for multiple values of a column, you can say over here columns of what I want is professional colon LOC comma versions of 3. Okay, and let me press enter. Sorry, something had gone wrong. Just give me one sec, guys. What had happened over here is it didn't come down to the next line. Just give me one sec. So let me scroll up. So get sample professional colon log comma versions of 3, and I will close my curly braces. See how it will give me all the values for the location. See, retrieval and inserting of data is very similar. Okay, Manish was saying if personal is 3 and professional is 5, then we enter a 4th record, it would drop the first version of personal and the second version of the version is at the column family level. So that is one attribute that I wanted to show you. So for all the columns inside the personal column family, you can have 3 copies, and for all the columns in the professional column family, you will have 5 copies. That's what I wanted to show. So, hey, if you add a 4th copy, in case if you say that you wanted to have one more copy, the first one will be removed. So now let's go ahead and do a little bit of theory. I have given you the complete demo. So I hope, hey, what do you mean by sparse database? Let me go back and explain that. So let me do a scan real quick. Yeah, there we go. So you saw how Vijay did not have a professional column family and Praveen does not have a personal column family. So that is the way how sparse works over here. Make sense? So not necessarily all rows will have values for all the columns. This is by default you will get nulls in your RDBMS. Here there is no nulls. That is the beauty of it, guys. So that is a sparse database, and automatic sharding would mean the data would automatically be spread across multiple machines. Hey, Srinivas, can you please show the files for these columns? If you talk about the actual files is stored in your HDFS. Okay, so if you wanted to see the browser link for it, just give me one sec. So I will go down to my Cloudera, Edureka, just give me one sec. And if you go down to the browser, okay, the actual data will not be shown to you. If you wanted to see the actual data, there is something called as Phoenix, which is a layer where you can see all the data. You can search for HBase, Phoenix, Phoenix. See over here is a relational database layer delivered as a client embedded JDBC targeting low data for HBase database. So this is what is the thing that you will have to look out, Srinivas, in case if you wanted to see how the value is going to be stored. Okay, but quickly I can show you within the VM. So if you go down to I don't want to go down to the name node. Let me go down to the name node. Let me click on browse the file system. Let me see where they are by default storing. They have to be storing by default in some location. So I just wanted to see whether they are storing it in my, I need to look at my XML file. Just give me one sec. So that will give you the place where the actual data would be stored. So I need to go down to my places. I need to go down to my computer. Just give me one sec, friends. He wanted to see where the data is stored, so I'm trying to help him out with that. I'll go down to my user. I'll go down to my lib. I will go down to my HBase. I want to open up my HBase-site.xml. Okay. So I will go down to HBase. Let me scroll down. Yeah, there we go. In HBase, I will go down to my conf directory, in which there is HBase-site.xml. Let me double click on that, and I will say display. So let me open up the XML file and see what the XML file is all about. So the root directory is, see, HBase storage. So inside my HBase, there should be a HBase storage directory, root dir. So let me go down to, yeah, I should see that in a editor. Give me one sec. This is the pain, you know, that number lock will keep on coming over here. It's pretty irritating, you know. I have to, somebody had mentioned how to avoid this number locks. I think by doing the details, you will see it, HBase-site.xml. Yeah, that's correct. So now what I wanted was, let me open up my this link, and I will say localhost : 500, just one sec, 600, what is the ID? Suddenly I'm blank. Yeah, 60010. Let me see if they have it. See, this is where the master is. 60010 is the default levels. If you look at the table details, see over here, the same thing what I saw in the sample table and scores that is mentioned. And if I click on the sample, click on the sample, it'll show you how the details are, etc., on which region server it is. If you click on this region server, it will take you to the 5001030, the region server status, and these are the store files what is available. So you will see where the details are. So this is the way how you will be able to see it from the browser. Like we have got name node status and we have got our job history server, right? The same way we have got all of these values. So where are we? Let me go back to the PDF. So I have told you how automatic sharding happens. Okay, so that is taken care of by the framework. I don't have to worry about it. So let me move on. So this diagram shows to you about the what I showed it to you in the NoSQL page. So you will have different kinds of NoSQL categories. Okay, so there is key value stores. There are big table clones. So big table clones are nothing but columnar data store. You have got document data store, and then you have got graph data stores. So different categories of NoSQLs is what we are having, and we are showing you the metrics wherein we are talking about scalability and speed. So if you talk about scalability and speed, your big table clones are the best. But if you talk about query and the navigational complexity, graph database are the most complex, whereas key value are the fastest. So just wanted to let me know about how, let me let you know how this actually happens, okay? So this is the way how the NoSQL landscape would look like. So this is about the cap theorem, what I have already shown it to you. So availability means it's always accessible and operatable at all times. Consistency is commits are atomic across the complete distributed file system. And partitioning would mean only a total network failure will cause the system to respond incorrectly. In case if a single node or something goes down, still you will be able to work with it. So just showing you that HBase is a type of CP. It is consistency and partitioning. Cool. So Srinivas was asking, we cannot say that this best over there, out of all, DB may give a better yield. Hey, that's true, but then in case if you want some functionality, okay, then you would need it. So it all depends upon the type of use case what you're having. Okay, so and by the way, if you wanted to see what is the total number of NoSQLs what you have, okay, again I will just go down to NoSQL. You will see there is a site called as NoSQL-org, NoSQL-database.org. There are more than 150 NoSQLs what we have. Okay, so the industry is so big that there are 150 NoSQLs. You will really have to choose what is the right NoSQL that you want. Okay, so this will give you the list of NoSQLs, NoSQL databases, and Apache.phoenix.org is a RDBMS layer above HBase. Okay, friends. So and now in case if you want to have a quick comparison between all of these things also, there is a very good architect of NoSQL called as Kovacs. Okay, and he has given a very good article about comparison between the different NoSQLs. So let me copy that first and show you comparison between NoSQL databases. Okay, so this is one of the best link what I have seen until now on that. That's the reason I'm sharing that with you. So if you scroll down, we are interested in HBase. So let me only go down to HBase and see what it is. So there we go. So what is HBase? It is written in Java. Okay, main points is billions of rows and millions of columns. It is modeled after Google's Big Table. It uses HDFS as a data storage. You can have Mapreduce with Hadoop. It is optimizations for real-time queries. It supports Thrift Gateway. It supports all type of serialization like XML, protobuf, etc. It gives you random access performance like NoSQL. Okay, so these are some of the best examples of how NoSQL can be used. So please focus on these things, guys. Okay. Now let's move on. So if you wanted to have a definition or the feature list of what is HBase, it has all of these things. You're welcome, Srinivas. So HBase is a NoSQL database, non-relational, which stores data in key value pairs. That means primarily it is sparse. You know what is sparse? It's a sorted map. That means it's a byte array over a byte array. It is distributed. It is consistent. And how is it multidimensional? Because you have got 3 levels of dimensions. Okay? Fantastic. Good. That's it. So let me go down. Let me have a look at the questions over here. The version of HBase that we'll be working with is, although the HBase 1 is already there in the market, okay, but we will be working on an earlier version. So let me check which version do we have. We had that before. Yeah, 0.96.2. That is the version that we are working with right now. Although version 1 is already there in the market. Hey, that's right. So the multidimensional is not the 3. Multi-dimensional would mean you can look at different dimensions. That means you can look at it from a column family and a column level. You can look at it at a row level, and you can look at it at a value level. That is what is the meaning of multi-dimensional. Okay? Not necessarily versions. Okay, version is at a single level. For a single value, you will have 3 levels. Okay? Yes. So if you look at the history of the HBase server, you would see that everything came through a white paper. Then it was immediately, Mike Caffarella is the guy who started with this white paper. Then it came into the Hadoop contribution in 2007. It became a sub-project. It became a top-level project. 2011 it was 0.92, and in 2015 version 1 of HBase has come. So if you simply search for HBase, the first release of HBase is already here. So see over here, if you click on this hbase.apache.org, you will see that version 1 is already released about 2 to 3 weeks back. Okay, see here, why would I use Apache HBase? When you want to have random read-write access to your big data, is hosting of a very large table, billions of rows and billions of columns across your commodity hardware. Okay, it will give you linear and modular scalability, strict reads and writes, automatic and configurable sharding, automatic failover. A lot of features are available, and you can actually see, where is that? What is the latest version? Where do I have the download? Let me click on the Apache HBase. Let me click on the downloads. Version 1 is already there, I know. So if you click on this link for the download, version 1 has already been available. So you can actually download that version 1, friend. For some reason it is just hanging for me. See here, HBase 1. So this is the stable version, and you can see this came in February of this year. Very recently this version had come. Okay. Very good, Dheeraj. So he is actually using version 1. Hey, that's right. So Annie is on a holiday, so that's why we still haven't got the questions. Our team is still working on Annie asking questions, guys. Okay, cool. So these are the various releases that we have. So if you wanted to quickly compare, although we have already done that, if you want to quickly compare between HBase and RDBMS, HBase is column oriented, whereas RDBMS is row oriented. HBase will have a flexible schema wherein you can add columns on dynamically, whereas RDBMS has got a fixed schema. HBase is very good with sparse tables, we discussed that, whereas RDBMS is not good for sparse tables. Of course, there is no Mapreduce in RDBMS, which is there in your HBase. There is a tight integration with Mapreduce, but obviously where nothing called as Mapreduce in RDBMS. You can have a very good horizontal scalability in HBase. RDBMS is difficult to shard and scale, and HBase is even good for semi-structured data and structured data, whereas RDBMS is good only for structured data. Okay, so these are some of the important comparisons between your HBase and your RDBMS. Although HBase is for structured data primarily, don't get misunderstood by this. It can take semi-structured data, but then it is good for structured data. And the main advantage of NoSQL or HBase is the random read and write performance. So where do I use HBase? If you have got some semi-structured or unstructured data, when you want to have high scalability, when you want to have different versions of data, when you are generating data from a Mapreduce workflow, when you want column-oriented kind of a data storage, and when you want high volume of data to be stored. Okay, so if you have got any of these capabilities, or sorry, any of these requirements, the best one that can be there for you is your HBase, guys. When should we not use HBase? When you have got only a limited amount of record. Please note HBase learning curve will be there because you are not going to work with what do you call the typical RDBMS kind of commands. Okay, so if you are familiar with RDBMS, that would be the challenge. You typically don't have those capabilities. And when you have got a hardware which is having less than 5 nodes and the replication factor is 3, then HBase might not be really be helpful. Having said that, HBase can run very beautifully on a single desktop, like for a development environment like what we're having right now. So these are some of the features when you cannot have. What do you mean by 5 data nodes? For HBase to be properly used, it should be, the sharding should be in a bigger fashion. So if you're having 3 levels of replication and if you've got only 5 nodes, okay, you would not get the best benefit from HBase. It's like saying that I'm having a very fast speed kind of a vehicle and I am doing it in a place where there's a lot of traffic. I really cannot use the capability of the speed over here, right? So if you look at the organizations who are using HBase, I told you HBase, Facebook is using HBase for their messaging system. So there are a lot of good articles on the net as well as on YouTube wherein they discuss about what is the architecture of a Facebook Messenger. So there's a lot of stuff that you can look at. So if you look at the messaging system, Facebook monitored their usage and figured out what they really wanted was a system that can handle 2 types of data patterns. A short set of temporal data that is volatile, that keeps on changing, and an ever-growing set of data that might rarely get accessed. So they wanted something which will give me the storage capability and the randomness capability of getting the data, and that is what HBase gives it to you. So they wanted something which is real-time, column stored, distributed, kind of key value, because here the key is going to be your row ID, linearly scalable, robustness and scalability a part of it, and of course the data is going to be big and it has to be open source. So this is how different organizations are using HBase. So this is Facebook usage of HBase. If you want to have a list of other companies who's using it, Twitter is using HBase for their people search. StumbleUpon has been one of the pioneers for HBase's movement. They are using HBase as a real-time data storage and analytical platform. Explorers uses HBase cluster for storing and analyzing billion anonymized clinical records. Yahoo uses HBase to document fingerprint for identifying duplications. The antivirus company Trend Micro uses HBase for cloud scale storage for a lot of different applications. You can also, like you have got Hadoop powered by, you can also look at this HBase powered by and get the list of organizations how they are using HBase, guys. Okay? So now, if you look at the components of HBase, like what we have seen, you will have the HMaster, that is the team lead who is responsible for coordinating with the slaves. You will have the region server, that is the individual slave machines where the regions are stored, and you will have a client who will first communicate with the Zookeeper. So that is what is crux. The client will always talk to the Zookeeper, the project lead. The Zookeeper will get all the details from the HMaster, and then you will have the actual data being accessed from the region servers by the clients. So this is the way how the HBase would work, folks. So just to show you how the data distribution would happen, remember I showed you how 1 to 199, 200 to 399. So whatever rows are there, it will get distributed across the multiple region servers. That is what we are trying to show over here. The same diagram is what I had shown it to you earlier. This way, if you're having a table, the way how the sharding of the data happens across multiple regions in different region servers. So that is what is being shown to you in this particular slide. So if you look at the HBase components, one, you will have the HMaster. You will have the region server. In region server, you will have something called as a memstore. So please note the final data is going to be in HDFS, but the memstore is the recently used data would be there in the memory. After that, the data would be written in the form of an H file to your memstore. Your Zookeeper is like a guy, a coordination guy. When you communicate with the Zookeeper, he will tell you where your data is. How will the Zookeeper come to know where the data is? Because he'll be updated by the H master. The val stands for write ahead log, like we have got edits file, right? In case if the region server goes down, since the edits are there in HDFS, you can recreate the data in a particular region server also. So we saw earlier how redundancy is built in our Hadoop. The same way redundancy is built in into HBase also. Hey, Srinivas, replication is taken care of by HDFS. Replication is not the responsibility of HBase. Because it is stored in HDFS, it is taken care of by HDFS. Cool. Now comes the conceptual part of it, what we just discussed some time back. A table is made up of multiple regions. A region is nothing but a set of rows that is stored together. One region server can store multiple regions, but one region will be available only in one region server. The H master is responsible for managing the cluster. And finally, all the data in your HBase is stored in HDFS, and it relies on HDFS high availability and fault tolerance. So that is what the integration is. Exactly. Region server is similar to your data node. Okay, so that's a good analogy. So remember, I had given you a kind of a chart some time back. So the name node is Zookeeper and H master. Your data node is what is your region server, and your blocks are nothing but regions. Okay, cool. So now this diagram gives you the complete picture of integration between HBase and HDFS. Okay. So although there are a lot of blocks over here, it is pretty simple and straightforward. Let me explain that to you so that you are not going to get confused. There will be a client who is an external person who wants to either read a data or write a data. He will first talk to the Zookeeper because the contact point is going to be the Zookeeper. Okay. So how will the Zookeeper get the data? He will be getting the data from the H master who is going to be interacting with the region server. The region server daemons are running on the data nodes. Okay. In the region server, you will have something called as H log, that is like your write ahead log. Okay, WAL. And where is that stored? It is stored in HDFS. Please remember that there is no one-to-one relationship between the region server and the data node. Okay, so whatever, because at the data node level, everything is going to be in chunks of 128 MB, because that is how Hadoop does it. So the DFS client that you see over here, that is a logical layer, okay, which will integrate between the HBase and the HDFS layer. There is no physical thing called as DFS client. We are just showing you it's a logical entity so that it will become easy for you. So remember I told you every region will have a H file. The H file is where the actual data would be, and that is what is going to be stored in the data node. Before it is stored in the H file, there will be something called as a memstore. Memstore is the most recently used data. So whenever you ask for something, or whenever you want to put something, it will be first stored in the memstore. Okay, and then it will be stored in the H file, and once it becomes a particular size of 64 MB, the store file H file gets persisted to the data nodes. You might have multiple H files there, so there is something called as a compaction that happens over here, which means merging the multiple H files into one H file so that it can be stored into the data node at an appropriate fashion. So all of these things are taken care of by the framework friend. Okay, so what do we have over here? A client talking to Zookeeper. H master is going to be the team lead. The region servers are going to be the actual developers. The write ahead log and the store file are stored in your data nodes, and memstore is something which will have the stuff in the memory. So these are the different components what we have, guys. Let me have a look at the questions window so that people can talk about it. So Srinivas was saying, when you say null to A3 will be stored in region server 1, it means that it is connected to 3 HDFS data nodes to store null A3 datasets. Okay, so see over here, what I meant by that is one region server data can be stored in multiple data nodes. Okay, and one data node data can be there in multiple region servers. It's many-to-many relationship. There's no one-to-one relationship over here. Make sense, Srinivas? Exactly, Vijay. The mem store is like a cache. 64, Srinivas was asking, is H file of 64 KB? It is actually 64 KB, but then after compaction, it can go till 64 MB also, Srinivas. So guys, I hope you are clear on this. Manish was asking, are region servers like typical commodity nodes? Any typical configuration? No, they are again commodity nodes. Please note the region server daemons are going to be running on the same machine where the node manager is going to be running. Don't think that they are going to be specialized machines or other machines. So when I said 132 node cluster, the 24 nodes that is running the region servers also have got node manager and data node running, Manish. So now, in case if you want to have a look at it, this is how a physical distribution would be. You always will have a name node, a secondary name node, maybe you'll have a job tracker, and you will have additional H master, which is going to be active passive. Then on the data node itself, you will have your region server, and that is the way how you can scale the horizontally across multiple machines. Okay, so this is the actual way how, just one sec. Thanks guys, I just needed to have a glass of water. So this is the way how your Hadoop, it will be scaling. How many instances of Zookeeper do we need? Is it one per region server or one per cluster? Very good point. There is a complete chapter on Zookeeper that we will be covering it up in the next session. Okay, that is on next Saturday. We will actually be doing that. In the module number 9 we have, typically you will have 3 or 5 or 7. Okay, so in our 132 node cluster, we have got people from different regions communicating. So we typically have got 5 Zookeepers. So Zookeeper is like a contact point. So you would typically keep a ensemble. It's not called as a cluster. Zookeeper is not called as a cluster. It is called as ENSEMBLE. It is called as an ensemble of Zookeepers. That means collection of Zookeepers, and it's typically in the form of odd numbers. It will be either be 1, 3, 5, or 7, depending upon how the lookup is going to be happening from the how many people are going to access it. So if you look at, see here, this is what we was talking about, the read and the write path. Okay, so the clients don't interact directly with the H files during the write. Okay, please understand that. It always talks to the your mem store. The read path, the data is first reconciled from the block cache, the mem store, and H files to give the client an up-to-date view of the row it is asking for. Got it? So you would always, whenever you write something, it is first stored in the mem store. Similarly, read, it is first taken up from the cache and then it is stored from the mem store. If not, it is taken up from the H file. The size of the H file would be totally dependent upon the data that you have. Good. Manish was asking, do different Zookeepers needs to intercommunicate? If yes, what is shared? Yes, they would need to coordinate with each other, Manish. So I just wanted to show you one diagram since Manish was asking me that. So let me go ahead and show you the diagram that I have in the next session. Just one diagram on Zookeeper is what I wanted to let you know. Let me go down. There we go. So this is a diagram I wanted to talk to you. So in a Zookeeper, typically you will have one leader. all updates will go through the leader, whereas all the other zookeepers will be serving the clients. So when anybody wants to do something, because the zookeeper gives you a guarantee of, will give you certain guarantees. He'll give you a guarantee of sequential consistency. That means the updates will happen in the order in which it was received. That is what the zookeeper will be doing, guys. So over here you will see that the zookeeper will actually, the guy who is going to be doing the update, the leader, everything will go to him, and he will send that information to the others, so that at any point of time all the servers which is serving the client will have the same information. Okay, so this is how an ensemble of the zookeeper would look like, friend. So now coming back to this, we saw how a client will go ahead and talk to the your mem store, or to your, and whatever you're doing, or to your H file, and everything will be persisted in the H log. So Srinivas was asking what will happen if the leader dies. Very true. It will select up another leader. Okay. So the leader selection and all of those things are the main advantages of your Zookeeper, Srinivas. Cool. So see over here. So if you talk about the HBase regions, HBase region by default is 256 megabytes. Okay, there is HBase site.xml, in which there is a property called as region.max file size. So you can keep an upper limit of 4 gigabytes. So by default the region is 256 megabyte, but it can go till 4 gigabyte. So if you are having a employee region, okay, like what I showed it to you, there is a personal column family and a professional or an address column family. So it will be stored as 2 separate files in HDFS. There would be a mem store, there would be a cache, and then everything will be there in the form of H file, which is all persisted in your HDFS. So a region would be broken up into multiple column families, and there would be a mem store at every level, guys. So see over here, a region in the employee table would be, see, one region server will have multiple regions. One might be for one table, another region might be for another table. Like I told you, one table can be in multiple regions and multiple region servers, and one region server can hold multiple regions. Cool. Hey, Ananda was saying, in the current example, 256 MB in a region is equal to 2 HDFS blocks. Hey friend, please don't compare the size of the region with the HDFS. Let me go back to the earlier slide. Like I told you, something that is very, very important for us to understand is there is no one-to-one mapping. See, this one region is actually there in multiple data nodes. See? This H-log is going to be over here, this particular value is going to be over here, this particular value is here, and this value is here. So one region data is there, see H file, is there in multiple data nodes. So please understand there is going to be no one-to-one mapping, friend. Okay? Good. Manish was saying, so a table can be of different regions across different region servers means a table can be across different nodes. Yes, very much. Okay, very good. So Srinivas was saying, HBase is purely local, not an HDFS, still it connects to HDFS, exactly. So, but then every log that you write will always be there logged in HDFS. Other than that, for the purpose of performance, it keeps up a local copy of it in the mem store, and then it will take it up from there. Make sense, guys? Good. So we were there over here just to show you how a single region can be there in multiple machines, and one region server can hold multiple regions. So see over here, if you're talking about a cluster deployment, HMaster is responsible to assign regions to each region server when you start HBase. So there are some special tables, lookup tables they are called as root and meta tables. So whenever you start with it, it will automatically take up the value. Manish was asking, is the region size auto expandable and what is the auto increment amount? Hey, you can specify the region, max region size in your XML file that we had shown earlier. So it can, let me go back to the earlier slide. See here, the default region size is 256 MB. Okay, there is nothing, and you simply give an upper bound. There is nothing that it will get incremented by X amount. Depending upon whatever records are there, it will keep on getting incremented. Good. So Manish was asking, what happens if it reaches 256 MB? Then that region will be sharded. See over here, friend. Let me go back to this. What is a region? Nothing but a set of rows, right? If it becomes more, the HMaster will break up that is what is sharding, and then it will put it up into another node. Got it, Manish? Good. So Srinivas was saying table 1, column 1 of can be on region 1 and region 2 on region server 1 and region X on region server 2. Yes. So it is many-to-one relationship. There is no one-to-one relationship between the regions and or region server and the data nodes. This is all going to be beautifully taken care of by the framework. We don't have to get involved in that at all. Okay? Cool, friends. So see over here, you will have a secondary name node, you will have a name node, active passive name node, you'll have a job tracker, you will have multiple zookeepers. See here, I'm showing you 3 zookeepers. And then on every node, you will have a data node and not a task tracker, a node manager. Okay, and on some nodes you might have region servers, and HMaster is always going to be active passive. So this is how a real life cluster deployment would be. Cool. Let me have a look at the questions window. So it'll go to region server only when in the case of sharding. Exactly. Okay, not necessarily it has to be 4 megabytes, but then you decide what is the upper limit. Hey, the name node is still the single point of contact, but now you have got active passive, right, Manish? We saw that in the Gen 2 architecture, there is active passive. So if the active goes down, passive will come up. We have seen that, federation and all of those things, right? Hey, that's correct. The name node is still a single point of failure, but then you will have active passive. That means if the name node goes down, okay, it will go down to the passive. That's what we're trying to say. Cool. Fantastic. Okay, that's nice. So if you are an HBase client, okay, if you want to get to a particular data, how will you get it? This is how step by step you will be getting that information. What happens when a client interacts with the HBase system? Primarily he will of course interact with the Zookeeper. Now the client wants some record number EMP. It will first look at the root table. The root table will have the details in the meta table that is there in the region server, and then the meta table will have the details in all the different region servers. So based on where it is, so where is this root and meta table? This information is picked up by the Zookeeper and given back to the client. Okay, and then the client will actually go down to your actual region server and then access the data. Like the same way what it happens for a normal environment, like what we have in our Hadoop. You will communicate with the name node will give a data, and then you will go ahead with it. Exactly the same thing is what is going to happen here too. Cool. Let me have a look at the question. Okay. Hey, what do you mean name node? I didn't get that. I was giving an example of HDFS. That's why I use the term name node. Here it will be the Zookeeper and the region server. Okay, cool. Exactly, Srinivas. All of these things are XML-based files. Cool. So remember, we spoke about what will happen if the size becomes big. So there is something called as compactions that would happen, friend. So HBase writes out files as the data is added. Each store will contain row, key, ordered files. It is immutable because more files will accumulate over time. So internally the framework has got something called as compaction, which will rewrite several files into one, so that the more lesser files you have, more faster it will be for you to access. And major compaction rewrites all the files into a store into a one. That is the time when if you have got some old versions, etc., it is deleted. We are just showing you the internal working of how the Hadoop will work. Okay, cool. Sorry, HBase will work, not Hadoop. Jeshri had a question. She said, so here also we have got two masters, passive and active. Very much. Okay, so if you go back to the earlier slide, Jayashree, you see that there is an active and a passive H master. So that is very much needed because in the new environment that we are having nowadays, it is must that we should have an active passive environment. Okay, so this is what is compactions about how the file will be written back to HDFS. So now, what is the exercise that you will have to do, guys? You will have to look at the Advanced Hive code. I'm sure all of you would have already done that. Okay. Hey, Srinivas also had, just once again, page number 50. Okay, so see, there is something called as a major compaction and a minor compaction. In a major compaction, all the files are chosen. What do you mean by heuristic? Heuristic means the last in first out. That is a kind of a algorithm. It's an algorithm. So if you have got multiple files, it won't wait till all the files become full for to do some compactions. So the master will take care of compactions, small compactions, and it will have one big compaction. The small compactions is what is called as minor compactions. What all files I wanted to compact, that means join together, is based on a heuristic algorithm. That is what is the last statement in your slide number 50. Srinivas said, so we will have to manually bring up in the active dice. No, my dear, if it is active, passive, it will come up automatically. There is no manual involvement over there. Okay, good. Hey, both of them are same. Good point, Dheeraj. Dheeraj was asking me yesterday when we look at a function and a temporary function. So both of them acts like the same. Okay? Good. That's correct. Similar to garbage collection. Yep, that's a good analogy. That's a good analogy, Manish. Cool. So now you will actually go ahead with this hands-on of Hive. So last week, yesterday, whatever we have done, please work on with these things. There are some further readings, Introduction to NoSQL, HBase Architecture, Basics of HBase. Please read all of these necessary things.